I will speak. This is a workshop on data analysis in Excel. As you know, Microsoft Excel is the world's most popular program for data analysis, and it's a versatile, user-friendly program that comes as a part of Microsoft Office. It is a program that allows you to analyze data, to make charts, and to perform, I would say, fairly moderately advanced statistical analysis. So we'll start with the possible sample graduate students research project. So, typically it could be a questionnaire survey or an experiment. It could be a before-after study with an intervention. You may have done a lab experiment, maybe on some materials in material science, or on some chemicals, or on animals in health sciences. So you would collect data before and after, and see if there has been a change. And you want to do data analysis and some statistical analysis to see if your intervention made a difference. So this is a typical scenario for a graduate student's research project. It can just be a questionnaire also, and even in that case, you would have maybe you can divide your study participants into two groups at least. An experimental group in which you did the intervention, and then a control group, which are for comparison, which you did not do the intervention, and you want to see if the outcome measure is different in the two groups. As you know, I have presented to a few of you before. I don't like the terms independent and dependent variables. I prefer the terms predictor variable and outcome variables. So predictor variables are variables that will help to predict if your intervention makes a difference or not. And the outcome variable is the important variable that you're collecting after this, at the end of the study, to see if there was a difference between the two groups. And you can have data collected like things like demographic variables, age, gender, education. You could have an initial score. Maybe you're doing a classroom study, or maybe doing a diet study. So you have the people's weight before the diet, and then after you put them on a low-fat diet or some kind of a diet, and you have a final weight, initial score, final score, something in that nature. So I hope this all sounds familiar and is something that you can relate to. So with that kind of a data, you should end up with a spreadsheet, on an Excel spreadsheet that looks something like this. So now you have age, maybe the gender of the participant. If this is maybe a questionnaire survey, and then the groups, you have two groups, the intervention group and the control group. And then their initial score and their final score. So a baseline measurement, and then a final measurement at the end of the study to see if there was a difference. And this, it can be applied to a lab experiment, to a questionnaire survey, to a classroom experiment, to an engineering experiment with materials, to a computer science experiment. So all these experimental studies have some kind of data that results like this. So let's get started. So I've divided the workshop into 4 parts: essentials, data entry, descriptive analysis, and statistical analysis. So in the first part, in the essentials, we will discuss Excel interface elements, the ribbon and its tabs, and some keyboard shortcuts. So this is the Excel interface as of recently. I just made the screenshot a couple of days ago. It keeps changing now. Excel has become almost like a website. So it is, as Microsoft updates the program and makes new changes, it just releases them on the fly. So now they've even stopped kind of doing the version number. They have, you know, they used to have Excel 2017, Excel 2007, Excel XP. Now it's Office 365, and the changes are just live, and new and exciting features keep coming up. And I was reading actually about the latest one that there you can actually write a short program in the cell itself. So instead of a formula, you can even write a small program that's easier to debug than writing a complicated formula. So the program keeps developing, and it's actually now full, you could say even bursting with features. But does anybody remember this? This was before the ribbon, and you know, you can see the toolbars and the icons. I'm sure some of you will remember this interface. Looks a little bit clunky now, but this was Excel a few years ago. And this is Excel maybe very early on from 1987. And look how it looks. This was a time maybe some of you were not even present. And Excel is now, I would say, at least 30 years old program. Has come a long way, as you can see from this initial interface based on early versions of Windows and DOS. At this time, I was in high school, and I think I've used early versions of Excel. And you know, over the years, I have learned quite a lot. I've done a lot of data analysis in Excel, and I kind of enjoy it. It's a good program, and I'll show you some of the features that are not so obvious. So now Excel is just Microsoft Excel. It doesn't have a version number, just comes with Microsoft 365. You know that all of you are eligible to get a free version of Office 365 based on your university email. So just sign on to office365.com with your university ID and password, and it will, you can download, I think, up to 5 copies on 5 different computers. So this is the current version of Excel. And here's a poll for you. So if you can maybe reply in the chat box where you are on a scale of 1 to 5. Let me see where. If you want to. I was thinking of using the poll feature in, we've got some 5s and a 2. Somebody's at 4, a lot of people at 4. I was thinking of using the poll feature in Zoom. Maybe on the next workshop. I think I'm doing a couple of workshops next week on Word and Jamovi. We could use the polling feature in Zoom. So 5, 4 and 2. So people are kind of divided between 4 and 2. Yeah, I wish it could be easier to use, but I like it also. So I think we're on the same page. Nobody at a 5. Maybe a couple of people at 5. I saw somebody, or you don't want to admit it, maybe. All righty. You know, there is alternatives to Excel, including OpenOffice, and this provides pretty much the interfaces looks similar to the older versions of Excel, and it has all the functionalities that you most likely need, like basic mathematical calculations and statistical calculations. It's free to download. So once you graduate from the university and you no longer have access to Office 365, you could think of using this. Or you could, you know, buy Office 365 if you really like it. So you have options of apart from Excel, and not to mention Google Sheets. So if you have a Google account, you have the online Google Sheets, which I think can work offline also. So you know, that's an option. Of course, it doesn't have as many features as Excel. Okay, now I'm going to switch to Microsoft Excel. Okay, so can you see Excel on your screen now?
Yes, yes, doctor.
Okay, great. All right. Okay, so I have opened up here what is kind of a file that I tend to receive when people have entered their data. And you can see it has a fair amount of formatting and different features. I'm going to come to that in a little bit. I'm going to hide this for now. So open a new worksheet. Um, let's go over the Excel interface quickly. So this is the Home tab. I'm going to use what's called the Spotlight. Okay, can you see this red dot? So I can point. Yeah, okay, great. So this will help me to point at, oops, no, I need to turn it back on. Okay, so as you can see, this top part is what's called the ribbon. Let me try and highlight that. So yeah, this is the ribbon, and it is one of the newer features in Excel. I mean, it has been around for a few years, but it is a major change in Excel's life compared to the previous toolbars. Um, Let me expand. Okay. So you have the standard paste, cut, copy, and format painter options as in Word, and some of the font formatting here. You can change the direction of the text in a cell. You can also use Word text wrap. So let me show a text wrap for you. So if you have a long variable name that is, you could resize the column, or you could use text wrap to make it fit. So if I shorten it and turn on text wrap, it is not. Um, yeah, yeah, now it's working. So it will force all the text to be visible, and by increasing the height of the row. So you can maybe the top row, you can select the top row and enable word wrap text to make all the text visible in the top row. The merge options can help merge your cells. This is totally not recommended in data analysis because it will create tables of uneven shapes. So don't merge cells if you're doing data analysis. You have several data types in Excel. You can change the data to number. That is the most commonly entered data type. And this will give you some decimal places. I'm going to put some data here. And if I change it to the number format, you can see I have a couple of decimal places added, and Excel will treat this as a number. If you want to force this cell to be a text, you can enter an apostrophe here, and this forces it to be a text and not treated as a number. And you can see this small green triangle at the top left of the cell that indicates that this has been changed from text from a number to a text. And I'll change it back to a number. You can also add currency symbols if you're using accounting data. You can use a percent style formatting. It adds a percent value to it. Let me turn it off, which it is not doing. Okay. Change it back to number. And you can adjust the number of decimal places that are displayed. So it doesn't change the value of the number, but it's good to reduce if there are too many decimal places showing. Maybe you want just 2 or 1 decimal places. Conditional formatting is also useful if you want to highlight certain cells. Let me switch to another worksheet, and you can see at the bottom I have 4 or 5 worksheets that I'm going to use in this workshop. So I'm going to switch to this worksheet and I'll show you formatting, conditional formatting. So you have formatting cell rules. If you want to just see the top 10 items or the top 10%, it shows that, I have the top 10% is only 1 item here because it's a small sample. You can also have data bars in different colors, for example, blue, green, and it gives you a visual picture of the values in each cell. So it's a nice way to look at your data right inside Excel without having to generate a chart. It can be solid or what's called a gradient shaded fill. You can use color scales. These are also nice to give you a heat map kind of picture. So you can see that here the low values are in red, whereas high values are green. And if you change it, now your high values are in red and the low values are in green. And you have some other options also. So you can choose whatever color scheme that makes sense based on your data. Again, this is good for checking your data and validation. Also have icon sets. So, you can show which numbers are in the middle, which are high. You can have these traffic lights, rating like symbols, so stars that are partially filled, or even small graphs within the cell. So a lot of ways that you can see your data, how it's distributed without having to draw a chart. Format as table, I'll come to that in a bit. This is very useful feature. And what it does is it protects and kind of defines your data. Cell styles, just essentially to do with shading and coloring. You can use these and you can, like, for example, highlight a cell as having an outlier value. So you could highlight this. This will not affect the cell when you import it into a statistics program or even within Excel. So this is a useful way of just highlighting something that you want to discuss later on. Some of the standard insert, delete, and format options. This is a basic option for quickly calculating the average. For example, if you select the box or cell just below a column of values and you click on the option for average, it will quickly calculate the average. It will actually intelligently select all the cells without selecting the top label, so you get an accurate value. And here we have the average calculated easily. So this is a quick way to calculate some of the basic things like average or count or minimum, maximum. You have some of the fill options. If you want, you can generate numbers easily by entering the first number and then selecting the bottom left, just hovering your mouse over the bottom right of the cell and then dragging it down. If you press the, I believe it's the Alt key. Hold on, let me, if at least I think if you enter two numbers, you can have a series that is generated. Again, it's not behaving right now. Yeah, now, so if you enter the top two values, it will generate what's called a flash fill. And you can even generate a specific series. So for example, if you want odd numbers, it will generate odd numbers. And you can generate like days of the week or months of the year, but just by typing the first one or two values and then dragging the lower right corner of the cell. This is to clear formats, especially if there's a lot of formatting. So for example, in this worksheet, I want to remove all these colors. I can just select clear formats. So it removes all the colors and font formatting. So it's useful if somebody has sent you a spreadsheet with a lot of unnecessary formatting. Sort and filter are, this is a very useful button feature. So if you select, you can sort any column from A to Z. You can see the highest to lowest or the lowest to highest. So for example, this column, if you select the column and click on this, the sort, Excel will give you a warning that you should not just sort one column by itself, because then it will lose its alignment with each row. So you should always expand the selection. Even better, just click on the one cell in the column instead of selecting the entire column, and then click on sort from A to Z. So you can see the rest of the rows have also been sorted, and you can see the final score ranges from 44 to 84. You can also have custom sort. So you can sort by multiple levels. So for example, initially by final score and then by initial score. So, or you could then sort it by gender. So it's initially sorted by final score and then by gender. Filter is also useful. It can help you hide. So if I only want to see the scores of males, I will just unselect females here and then click OK. So now the data is only showing the males and not showing any females. So you can clear and clear all the filters with this simple button. Find and select is just basically search feature. Let's move on to the insert tab. We will cover pivot tables and pivot charts in the descriptive statistics. You can insert images, charts, pivot charts, 3D maps, and just lines within columns. So you could select select a column, and then it will display lines based on a set of data. Usually this is used for time series analysis. We'll cover slicer later on. You can insert links to websites. You can also post a comment. So if you select the cell and you can start a conversation like a threaded comment. So if you're doing I have multiple people collaborating on one spreadsheet, you can write a comment and that will appear as a purple annotation on the cell. And if you hover over the cell, you can just see it, and then someone else can reply to it. So again, this is a safe way to annotate your spreadsheet without writing text in the cell. So don't write text in the cell like this. Just it will kind of it may mess up the data analysis. So better not to write any kind of comments in the cell itself, but rather to use the comment feature over here. Page layout, this is mostly useful for printing. So you can view different, you can set your margins and print areas, etc. Okay, and you can even view print or view grid lines. So if you want to not print the grid lines, or if you want to print the grid lines, you can change these options here. Formulas, of course, is the lifeblood of Excel. It is what Excel is about. So you insert formulas here in the Excel bar. You notice that you can increase and decrease the size of the formula bar. This is the standard. And if you want, you can make it a slightly bigger to see things. Um, Notice that the AutoSum commonly used formulas are here easily available. You have a recently used financial, logical. I don't use most of them except if you go here in more functions, statistical, and you can see a very large range of statistical function, and we'll cover some of this in the last part of the workshop. Data. So you can import data as CSV files. So if you have a text file, somebody has sent you a CSV file, you can use import data from here. You can, of course, import from a lot of other sources, including online services, such as SharePoint. This is, or a databases also. Excel has now recently introduced some new data types, like such as stocks and geography. So, you can display information from the web. Excel will get information from the internet automatically and display some data related to that. For example, if you have a list of cities and you convert that into a geography data type, then you will get information about that city imported from the internet. We already covered sort and filter. And some other additional features that, again, I'll cover in data entry. Data analysis is, again, a plugin for Excel that I've added. If you don't see it, you will have to add in from the options menu, which I will show later on. The review tab is also fairly useful. It includes the option to write comments, as we discussed. So you click on a cell and enter a comment. Or if you want, you can put a sticky note. So, a new note here, and it will show up as a sticky note. And you can move it around. So, but it will create an arrow to that cell where you clicked initially as a comment. These comments, of course, don't have the threaded feature of the new comment feature in Excel. Another good idea is to protect a worksheet. It is recommended that you save the original data and you work on, when you're analyzing the data, you should work on a new copy of the Excel file, not on the original data. So you should always create a backup of the original data, and for analysis, use a separate copy of the Excel file. And the original copy, you should protect it by adding a password. You can also allow other users, if you have a shared Excel file, to edit only specific areas of the spreadsheet. So they cannot, for example, change the variable names on the top row. Now at the View tab, we are currently in the normal view. You can switch to a page break view, which shows how things will look when they are printed. And page layout view, again, also things how when they are printed. So you can see how your spreadsheet will look like, and you can change. You can also hide the ruler, hide the grid lines, hide the formula bar, hide the headings, which is the the 1, 2, 3 on the sides, and A, B, C, D on the top row. That gives you the location of each cell. So I'll switch back to normal view. A useful feature is freeze panes. So I like to freeze the top row. So I'm going to freeze the top row. And now if I scroll, let me just make this bigger so scrolling works. So if I scroll, you can see that the top row remains visible. And what I like to do is actually change the color of the top row also. So, kind of give it a very light color and maybe make it italics and change the font color. So all these things make sure you get a visual on that the top row is visible. So as I scroll down, you can see that the top row is frozen in place. So if you're adding numbers, you can see which column you're in. And finally, the help, which has links to online help. Okay, let me switch back to PowerPoint. Okay, now we come to the second part, the data entry part. And in this section, we'll discuss best practices, variable names, and data validation. At this point, if you have any quick questions, please do type them in the chat box. I can see it. So we have a question that if I insert a file, I don't understand. What do you mean insert a file? Can you maybe rephrase the question? Or if you want, you can use sound. You can speak it out.
Yes, please. If you want to use your mic, maybe we can unmute you. But please raise your hand so I can see your name on the top of the screen.
What do you mean by when we insert a file? You want to insert a file into Excel? I can understand importing data from a file. If you have data in another file, even a PDF file, which has, a table and has some numbers, you can import it. But to insert a file, I think if you want to create a link to a file or insert a Word document as a figure, yeah, you can do that. I don't recommend it. You can hyperlink it. Yeah, you can hyperlink to a website or to a Word file on your computer. But if you send the Excel file by email, your Word file, if it is a link, it will not go with it. I would not recommend inserting a file into an Excel spreadsheet. Why would you want to do that? Um, yeah, I think to import the PDF, then again, you probably want to copy the table. Just select from PDF, just use your mouse, drag across the table, and then paste it into Excel. Date and time this is for Mariam's question. This is probably we can discuss it at the end of the workshop. Okay, so let me move on. Any other questions? So, Excel spreadsheets are very much prone to errors. So you should be aware that in real world audits of Excel spreadsheets, they find a lot of errors. As you can imagine, it's pretty easy to make an error because the whole spreadsheet is open. You can type anywhere. Sometimes you start typing in Excel and you don't see there's nothing happening, and you type, and then you just move your mouse and then click again and then start typing again. So your initial typing happened somewhere. It probably corrupted a cell somewhere in Excel. So Excel is notorious for containing errors, and it is something you have to be very careful with. There is actually a website about spreadsheet risks, and they have horror stories about spreadsheet mistakes. And even with COVID-19, spreadsheets have caused a lot of data loss and data corruption. So you should be very aware about data entry into a spreadsheet. Be very careful. This is a nice article that discusses data organization in a spreadsheet, and I will go over some of the principles outlined in it. So let me switch back to Excel now. So we'll go back to the kind of data that you typically see when somebody sends you data in Excel. This is the kind of formatting that you're more likely to see than anything else. You can see that there's a lot of color formatting, highlighting, but what other problems can you see? For one thing, there are missing data that have been handled differently. Yep, alignment. Alignment actually will not cause a problem in analysis, but alignment is an issue. Here, actually, alignment is okay. Missing data is okay. Missing data is part of life, so you cannot avoid it. If you have a large enough study, you will get missing data. The key thing here is to be consistent. Yeah, thanks for about the professor's name. The gender? Yeah, look at the gender column. Look at how different the data has been entered. Sometimes it's with capital letters, sometimes with small, sometimes with the question mark. So the data analysis will not recognize this as consistent. So the big message here is be consistent. If you want to code gender as M, small m, then it should be small m throughout. So for example, over here, look at how gender has been nicely entered. It's either M or F, and it's both small letters. What other issues? Well, let me just mention the bold and Highlighting, again, this is ignored by Excel and data analysis. So this is actually harmless, and you can use highlighting to give yourself a clue that this is a problem data and it needs rechecking. It's better to use a comment. So better to write a comment here, like check, and post it as a comment. Score column. You could write it, a check mark and a question mark in a score column. Bold is also okay. It doesn't cause problem. But again, what I would do is I would just select all this and remove formatting. So don't use clear all, then you will lose all the data. So just clear formats. The other thing is, how do you handle missing values? Should you use something like 9999? Of course, that's a leading question. The answer is no, because if you forget to handle it, it may just average it with the other numeric values. So don't use a numeric value for missing. Some people recommend not leaving any cell blank. So you need to have some convention. You could use miss. That sounds nice. So you have a missing value that is clearly indicated. And the good thing is that Excel will ignore this. So if I average it, I get 46.7. And if I leave it blank, it remains as 46.7. But if I type 0, it changes. So 0 cannot be used as a missing value. You can use any text or even a hyphen. But hyphen maybe not be a good idea. So any kind of text would be nice, but it can be blank. It can be NA. Yeah, NA is okay, but just be consistent. And even if you leave it blank, as you can see, the average does not change. But blank is not clear whether it was missing or somebody forgot to enter it. So if it was missing on your then you need some way of indicating that it was a missing value. Also, your top rows should be clear. So all these headings are not needed and should be deleted. So I'm going to delete these top 3 rows. And also, there should be no extra text here at the bottom. So I'm going to delete this also. And delete this also. So now we have a nice rectangular data set with the top row being just the variable names. So a word about variable names. You can have a space in the variable name. That's okay now. Previously, people used to use underscore. That is also fine, unless you're going to import this data into a programming language like R. Space is okay. As SPSS can handle spaces also in this. It could be serial number or serial ID. Typically, names you should not include in the final data because of privacy issues. So once you start analyzing it and you have a backup copy, I would delete all kind of private information like medical record number, telephone numbers, address. That should be removed. Again, you can see here problems with coding. and issues with different accuracy number of digits here. So one way to make sure that the data entry is okay, you want to apply what's called data validation. So select a column, go to data, and then data validation. So this is the button here under data tab. And you can enter a data validation rule from data validation. So you want to, for the age, you want to have, well, you could have a whole number or even a decimal. And it should be, age should be 0 from 0, being newborn. And obviously you cannot have a negative age. And then maximum age, what's the maximum age that is possible in humans? What is the oldest age recorded? No, 90. I actually had a patient who was 101 years old. 198, no, I don't think so. 150 is too much also. So I had a patient who was 100 years old, 101, and she was brought by her son who was 80 years old. Yeah, I would go with 120, maybe to be on the safe side, 125. And you can add an alert message if somebody enters, any incorrect data. So you select whatever data you want to validate or check if somebody enters correctly. Click on the data validation, and then on the settings, choose whatever you want. Like you could have even a specific text that can be entered. So, again, here you have an IELTS score. What is the lowest IELTS score you can have? Anybody with experience? I guess maybe 0. And I think it goes up to 9.9. So if anybody enters an IELTS score of outside this range, you'll get an error. So here I'm going to enter an IELTS score of 11. And immediately I get an error message stating that your value is incorrect. So if I enter a value of say -1, again the same error comes up. So this is a good way of protecting your columns against errors in data entry. Another way is to add what's called speak cells on enter. So if I turn it on, doesn't want to turn on right now, hold on. So if I turn on speak cells on enter, it will act. So when I enter data, it actually, I don't know if you can hear that. So it actually tells you what you're entering. So this is again a great way to, for anyone who's entering data from a paper form. Another important issue is to write the serial number on the paper form. So you could even call this form number. So make sure you write the form number on the paper form from which you're entering this data. So if there's an error, you can go back to the form number. And I usually write the form number in big numbers on the top right of each paper form using a big marker. So it really sometimes saves the day. Another tip is to enlarge the view. So you can zoom in by clicking this on the bottom right. And so, people like me who are kind of growing older and getting presbyopic will really appreciate this feature. So when you're entering data, it's maximally zoomed. Um, Another feature in Excel is to assign names to each cell or column. I'll cover that maybe later on. Okay, let me switch to data analysis now. Okay, now we are at part 3. Any quick questions for the last part? So in this part, we will see pivot tables and pivot charts, including slicers, calculate the mean and standard deviation, and other descriptive measures. So I'll switch to this nicely formatted spreadsheet with data. I'm going to delete the names column. And we will do some basic things. First, I'm going to show you how to make this into a table. I'm going to select all the data and call it a table. So here under the Insert tab, I'm going to change it into a table. You can just press Control T, and this just asks you to confirm that this is the data you have. And now this is, in a way, it's protected. This is the recommended way to analyze data in Excel, is to first convert your data range into a table. This really speeds up, so you don't have to select anything. And I can now, do filters and sorts right in the table. So I can sort by, say, the IL score. I can sort by age. I can sort by group. And I can filter by group. So all these things, I can do it right now just within the table. The other thing is, if you add a row, the table will expand accordingly. So the selection is now fixed, and you don't have to worry about selecting any extra rows at the bottom. Okay, and so some basic statistics. I already showed you how to calculate the average. Let me show that one more time. So you go to formulas, auto sum, and average. Notice that Excel does not call it a mean, it calls it average. So I want the average. And again, you just want to select the data where you want, and that's your mean. And let's say I want the standard deviation. So I'm going to go to statistical and look for standard deviation. Notice there are two options for standard deviation population and standard deviation sample. Pretty much always use standard deviation sample, because population assumes that you have the entire population data. So if you conduct a census of a country, maybe you could use the standard deviation population feature. So now I've got options to select which data I want the standard deviation for. I'm going to select IELTS data. And that's my standard deviation. I can reduce the number of decimal places shown. Okay. And that's the most important two statistics that you will use in your research article, the mean and the standard deviation. Sometimes if the data is not normally distributed, you want to calculate the median. So let's say I want a median age. What you can just do is click on the formula bar and then type equal to sign. That will start a formula. So that's the way to start enter a formula, is to type equal to sign. And now Excel will give you clues. So I want a median. I'm going to type MED. And you can see that Excel is showing a tooltip median, and it even gives you an explanation, returns median or the number in the middle of a set of given numbers. So that's what I want. At this point, don't press enter because that will just truncate it. Press the tab key. Okay. So now it has entered the entire median word term of the formula, and with the opening parentheses, I'm going to select the age column and and now I can press enter. You could press the closing parentheses, but that's optional. Excel can do it for you. Notice that I have named this column as Excel is calling this table 1 age. This is a feature from the table creating tables. So it instead of giving you saying D2 colon D13, it gives you a nice name, table 1 age. So here we have a median age of 24.5 because the middle number is actually not the middle number is between 24 and 25. So that's why we have a fractional median value. And similarly for mode, maybe if you want to calculate the mode age, so equal to mode. And we have mode single and mode multiple. You just want a single value. So some data have multiple modes, but that will return an array. So at this point, we'll just stick to a single mode. And again, press the tab key. And I want to select the range and press enter. So that's our mode. And again, you can just enter these values in the text of the results section of your manuscript or thesis. I wanted to quickly show you about the pivot charts and tables. So pivot charts and tables are feature that Excel and Microsoft are very proud of, but I don't really find it useful and as a data in data analysis, but it seems to be more geared towards business users. It's something, it's easy, and you should use it to look at your data initially, to look for any errors, outliers, distribution, and just to see some patterns. So I'm going to delete all this for now. Okay. I'm going to select an empty cell and go to insert. And I could use insert pivot table, or I prefer to do this is to insert pivot chart and table. So I do both together. Okay. I'll select my table that I want to analyze and then click OK. So we have an empty pivot table and an empty pivot chart. Let me see if I can get the spotlight. Yeah, no, not this one. So I have this empty pivot table and empty pivot chart. The first thing you want to do in the pivot chart fields is to use the values column, values box at the lower right area. This is what will contain your data. So remember, the values is the most important one. And because our final score is the important, I will drag this as the final score into the values box. What it has done is use the sum. I'm going to change that by clicking on a value fields and change it to average. Because most of the time in research, we want to look at the averages, compare averages between groups or the means. So that's what we want. And we don't really look at the sum, which is, I think the sum is more used in accounting. Okay, so we can see the average final score was 64. But now you want to see, let's compare the gender. So legend is what you could call columns. They used to call it columns, or you can put gender in the rows. So here we have axis is actually rows. So you have female and male, and you can see that females had a higher average score of 66, while males had lower average score, um, um, as is often happens in life. So this is a quick way to, you can analyze, let's say you want to compare it by your group, intervention and control group. So I'm going to remove gender for right now, just to make it simple. You can see that the experimental group, the average score was higher. So your intervention worked. Your baseline score was 52, and your final score, your experimental group had a higher score. So it seems like that the intervention worked, and your control group did not improve their scores as much as the experimental group, which had ended up with a higher score. And if you want to slice it by gender, then you add, let's say, a gender row, and reduce the number of decimal places. So here, if you look closely, you can see within, say, the experimental group, females had a higher score. But in the control group, males actually had a higher score of 52 compared to 51. So these are the kind of analyses you can do. You could also say filter it. So if you only want to look at males, hold on. You can add the gender to the let me just see. Oh. Somehow my pivot table has come into the tables area, but you can also filter it. Again, as you can see, I'm not a big fan of pivot tables. It's, I think, more useful in business applications where you can see like the sales performance in different regions or by different salespersons. But I think you get a hang of it. Just remember that the values is the first box you want to fill, and change that to the average value. So then you can compare groups. But that's about it for pivot table. Okay, so now we move on to the last part. Any questions at this point? So now we come to statistical analysis, and in this we will look at calculating correlation coefficients, conducting a t-test and other statistical tests, and then using Excel add-ins for statistical analysis. Okay, I'm going to remove this. So let me just copy it. I think it'll be easier for me. Okay, here we are. So let's start with the same data. And we did the descriptive, mean, standard deviation, median, mode. That will cover a lot of ground for you. Remember, you can calculate the, say, mean by filtering or by selecting subgroups also. So let's look at correlation. Let's see if the initial and final scores are correlated. I'll select an empty cell, and I'll just type correlation here. And again, I'm going to click on the formula bar, type an equals to sign, and then type correlation, CORR. And you can see it is giving me a correl keyword. I'm going to press the tab key, not the enter key. And it has entered the entire term and an opening parentheses. So it is requesting two arrays, array 1 and array 2. I'm going to select initial score values as array 1, and then type a semicolon, not a comma, but a semicolon, and then go for array 2. And notice that I'm not selecting the top row with the variable name, okay? Notice also that I have actually named these ranges. So I'm getting a nice formula in the formula bar, correl, baseline, semicolon, final. And if I press enter, I get a correlation coefficient of 0.06, which is a low correlation, which means that the initial and final scores are not correlating with each other. A correlation coefficient of more than 3 is mild correlation, more than 5 is moderate, and I would say more than 6 is strong, 7 would be a strong correlation. Let me repeat that. Okay, so if I want to do a correlation, I'll select an empty cell. Yeah. And then click on the formula bar, type an equal to sign, start typing the keyword that I think will be it. And then I got tooltip, press the tab key. The open parenthesis appears. I'm going to select the first data column. Okay. And then type a semicolon and then select the second data column. And then close the parentheses and press enter. So here, wow, you see a nice correlation between final score and IELTS. So a correlation of 0.96. This is something you don't see in real world research of a correlation this high. If you see a correlation this high, probably you need to check your data or some other, maybe there is a covariate or a confounding factor that is linking the two variables. So that was correlation coefficient. Now we want to, let's say, check if the experimental group and the control group, we want to compare these two groups for their final score. We want to know if there is a statistically significant difference between the experimental group and the control group. This again, you can use the formula bar and do a t-test or a one-way ANOVA. At this point, I'm going to show you how to use the analysis tool pack. So click on data, and if you don't see the data analysis button here on the top left, top right, then you need to go to File, Options, Add-ins, and then Manage Excel Add-ins. Click on Go, and then select this analysis tool pack. This comes free with Excel. You don't have to download anything. So this is a statistical analysis add-in for Excel. And then click OK. And this button, data analysis, should appear in your data tab in the ribbon. Okay, and if you click on data analysis, a small window will appear, and you can see you have a fairly reasonable range of statistical tests, including Anova, descriptive statistics, t-tests, as well as regression. So let's start with single factor Anova to compare the two groups. I'll click OK. And you have to give an input range. Over here, this again is, we're seeing some limitations of Excel. They want a range of 2 columns side by side, while we have data in 1 column. So I'm going to rearrange the data. So experimental group, just copy it, paste it here. And the control group, copy and paste. So now I have the 2 groups side by side instead of in 1 column. Hold on, this is the initial, okay. So I'm going to click data analysis again and click on single factor ANOVA and select this range now into 2 columns. If you have labels in the top row, then you would select this box, otherwise you leave it. And the output will come in a new worksheet. So here's the new worksheet. And you can see that the mean is fairly similar in the two groups, 47 versus 44. P-value is not less than 0.05. So this is a non-significant difference. Let's compare the final scores by Anova. So I'm going to copy, or let me try the t-test again just as an example. So this is paired t-test because we have values for each person before and after. So variable 1 is the initial, and variable 2 will take it as the final score. And again, I've not selected the top rows, so I'm not going to check the labels box. So here, these are the results on a new worksheet. And you can see that the p-value is both on a one-tail and a two-tail. Normally you look for the two-tail test. It is significantly different. So the mean scores have improved from the baseline of 45 to 64. Let me do that one more time. Let's say you want to compare the final score of experimental group. I'll paste this with the final score of the control group. Okay, and again, now I'm going to use data analysis tool pack and single factor ANOVA. So select this range. And again, I don't have labels in the first row, so I'll leave this box empty. Click OK, and here you can see the average in the two groups is quite different. The intervention group, the average is pretty high, 76, whereas in the control group, it's 52. And look at the p-value, it's quite low. It's fairly, and it's well below 0.05. So this is a statistically significant difference, and you can tentatively say that your intervention worked in improving the scores. At least it was statistically significantly different. Notice that the variance is different in the two groups, so you have to adjust for unequal variance. And again, this is beyond the capability of Excel, so you would have to use a proper statistical program to do that. Okay, so close this. Okay, last thing I want to show is regression. You can actually do regression in Excel. So if you want to see if the final scores uh, are predicted by the initial score or the IELTS score or the patient, or the age or parents' education, so you have multiple linear regression available in data analysis tool pack. For that, all your predictor variables should be in together. So I'll have to cut the age and insert it. So all my predictor variables are right next to each other. So these are my predictor variables. They are now together next to each other, and I have the final outcome measure in a separate column. So now I can do regression analysis. Again, I'll click on data analysis, regression. And I just want to mention that descriptive statistics is also a useful option. It will give you everything from standard deviation, median, mode, kurtosis, all those things that you need, the range, the minimum, maximum. So it's a nice way to get all your descriptive statistics in quickly. So for now, I'm going to try regression. Click on regression. OK. So input Y range. Y range is, of course, your final. So I'm going to select final. And your X is your predictors. So I'll select, hold on, I think I'm not sure. Yeah, so let me change this to include the top row. So I have the labels with it. And then for my predictors, I'm going to select all the data, including the labels at the top row, but not the final, the outcome variable. So this X range is the predictor variables. It can be more than one. And the Y range is just one column, which is the output or outcome variable. Okay, and then you can have other things like residuals, standardized to see how good your prediction model is. You can have line fit plots and normal probability plot to check if your data is normally distributed. So this is our regression output. And here you can see that if you look at the p-values of different variables, you can see that none of them are good predictors of the outcome variable. So yeah, unfortunately, in this data, there is no good predictor of the final score. And an important parameter in prediction is the R squared, which is 0.92, again, very impressive. Probably because of the IELTS score. I was expecting IELTS to be, actually IELTS is highly, yeah, the p-value is actually very low. It's less than 0.05. So IELTS is actually highly predictive of the final score. And you can see it in the adjusted R square. This is, again, this is something that you will not get in real life. Most of the time, R square is like around 0.3, 0.2, and we are fairly happy. But I also, like an R square of 0.9 means that you have a very good predictor And that is explaining 92% of the variation in the outcome variable. So again, this looks like very much like a professional statistics output from, say, SPSS. So you can do quite a lot even within Excel. Okay, let me show you my last few slides. So question, which do you think is better? A Swiss Army knife or a simple screwdriver? Again, I should have done a poll. I guess the answer is it depends what you need. Excel is more like this, the Swiss Army knife, okay? Um, and it is very versatile, but it is, again, it can be, um, maybe not suited. Let's say if you have fairly tight, you need a lot of strength, then you would need a screwdriver, proper screwdriver, and then you'd need a professional statistical program like Jamovi. So I don't really recommend using Excel for statistics. It is not, it's too error prone. There's a free statistics add-in for Excel. They call Excel Stat. There's a trial version, plus there's a free version that can do a lot of these tests. So if you really want to stick to Excel, try using an add-in like Excel Stat. I don't use it. And then, Excel should not be used in production operations. So let's say you're running a factory or a clinic or a hospital or a lab. You should not be using Excel to enter and analyze data. It's just too error prone. And in real world, there are so many horror stories about Excel causing problems and data loss that it's better to use a specialized package for your industry. So that concludes the Excel data analysis workshop. I hope you enjoyed it. I liked interacting with you as always. I wish I could come to the F3 building and we could do it face to face. But as of now, it's via Zoom. Any final questions or comments?
Guys, please, if you have any questions, you can raise your hand. We can unmute you if you would like to use the audio or type in the chat. Please do fill the feedback form. I'll just keep the link in the chat.